Alright, here's a graphing problem that I will do for you and show you some of the ideas that I'd like to have you keep in mind when you make graphs on graph paper. The data, P and Q, the independent variable, that's the one that's going to go on the horizontal axis down here, will be P, and Q will be the dependent variable, which is the one we'll put on the vertical axis. So I look at the data that I've got, and I don't think that starting at 0 at the origin of this piece of graph paper is going to be convenient for numbers like this if I want to spread the data out as much as possible on this piece of graph paper. That is, to use the whole sheet. So I want my data spread out, so I'm going to make my Q axis go from, say, and this is up to you, but I'm going to start it at 68 units and go up to 76 units. So that will include all of these values. I won't try to get it exactly at 68.8 to start. I'll just start at 68. So that will be, well, I could figure that out right here. 68 to 76. That means I need, how many does I need? I need 8 units. 8 numbers on this axis from 68 to 76. Remember that you've got to make a linear scale. So if you decide that 4 squares is going to be 1 unit, then it's got to be 4 squares for 1 unit all the way up the piece of paper. You can't change them just to make it easy to plot these points. Alright, over on the other side, so I think that I've counted the squares ahead of time, and I know that there are 32 squares on the vertical line here, on the vertical axis. So I'm going to label it Q, and if there are 32 squares, I need 8 units. 4 squares per unit is a good scale, and that would make each square 0.25 units, whatever those are. Remember to include the units on this label. I'm not specifying what those are this time, but they would have units: atmospheres for pressures, liters for volumes, meters for length, whatever it might be. That would be included in your label for this axis. Alright, so now I think I'm ready to put the numbers on the vertical axis. 68 is going to be starting right here. Count up 4 units, 4 boxes that is, and that should be 69. 4 more, 70. 4 more, 71. Can't write that in there very well. 72. 73. I'll write that there. 74. Remember that this does not have to start at 0. We can still figure out the slope and the intercept. We can do everything, and we can really use the whole piece of graph paper. 4 more squares, 75, and then up 4 more, 76. So this is going to work out really nicely on this vertical axis for Q. Now let's put P down here. We've got to go from 0.042 to 0.054. That's 12 units if you're looking at the thousandths place of these decimal numbers. So I've counted the squares across here, and I know that there are 24. So I could actually start this graph at 0.042 and end at 0.054. and use the whole thing. Now that's just fortunate. The paper wasn't designed for this problem, but that looks like it's going to work out because there are 12 units from here to here. If you think of a unit as 0.001, whatever they are, whatever P is. So again, it has units. All right, so where will 0.043 be? How many boxes will each of my units in the P values take up? Well, if there were 24 squares and there are 12, a difference of 12 units here between here and here, 12 numerical values, then there'll be 2 squares for each one. So I'm going to just mark those off. This would be 0.043, 0.044. And sometimes you don't have to mark every one. You just make sure it's linear, that it's the same for every one. So I'm going to do the even numbered. Those are the ones I'll label, those values. 2 more, 2 more. 051, 052, 053, 054. So there's everything labeled, everything laid out, and now I can plot the points very easily. I'm going to have to do some interpolation because I clearly see that if each one of these squares was 0.25 units, well then 0.2 is not right up on that line, it's going to be a little below. So 75.2, well here's 75, 0.2 is just a little above, 0.042 on the x-axis, so I'm actually plotting a point on the axis. It's going to be just a little up here. I'm going to put a circle around it and an X. I want these points to be obvious here when I make these on the graph. So at 0.046 I need 72.5. Well, 72.5 is easy to find. Here's 72. Here's 72.5. And I'm over at 0.046. So I follow that line up carefully. 72.5, I went too far. 72.5, 0.046. You got to be careful on graph paper. Everything sort of starts to look the same out there. 71.4 on the vertical axis. Here's 70. 71.4 will be somewhere slightly below 71.5, which would be right there. And 0.05. So I'm going over on this line. So that point looks like it would be right about there. Remember, this is the typical kind of thing that you would get in a laboratory course where you were making the measurements yourself. This may be supposed to be a straight line graph, but this is the typical error that experiments would have in them. So we're going to try to draw, when we get done with this, when plot the last point, we'll try to draw the best line we can through this data. The data will not necessarily be perfectly lined up, but that's okay. If we expect a linear relationship, even data that is not perfect can get you what that relationship is. All right, so finally for the last point, 0.054 is the x-axis, or p-axis in this case, and 68.8. Well, here's 68 on the vertical. 0.75 is right there, 3/4 of the way up, so 0.8 would be that far, say, above that. and it's way over here at 0.054 on the x-axis. So there's my fourth point.